Good afternoon, friends. So we were dealing with the first chapter, physical world. So in the yesterday's class, I have discussed about so what are the scientific method we have to apply to find an law. So that scientific method, what are the steps to be followed there, we have seen. And also we have seen what are the basic quest in the study of physics, basic thrust in the study of physics we have seen. Those are unification and reduction. As I mentioned, unification is the minimum number of laws should explain the different phenomena of nature. Different phenomena of nature must be explained by as possible as minimum number of laws. So that we say it as unification. As I mentioned in the yesterday's class, if a ball is falling towards the earth, the earth is revolving around the sun, moon is revolving around the earth. All these are different phenomena, different natural phenomena, but governed by only one law, that is Newton's law of gravitation. In the same way, other quest of physics is reduction, where the complex phenomena that are occurring in the nature can be explained, can be reduced, can be break into smaller phenomena, and those can be studied. So in the yesterday's class, I given the example of generation of current electricity. Even in thermodynamics, also we are using this reduction process, where the thermodynamics is a macroscopic study, but this can be explained by the kinetic theory of the molecules. This can be clearly explained by the kinetic theory of molecules. A macroscopic phenomena is explained by the microscopic phenomena. Okay, so that itself is reduction, as possible as divide into smaller bits. And so then it becomes very easy for us. So this thermodynamics is the best example for it. So moving on in this chapter, so we have been using the terms law and theory. In your lower classes, 8th, 9th, 10th, you have studied what the Newton's laws, theory, evolution theory in biology. So these we have been using Newton's law of gravitation, Newton's laws of motion, all the different laws you have studied in your lower classes. What this law means, what exactly it is, so that we will see now. So this law is the general statement is general statement of the phenomena, of the happening phenomena, of the happenings in the nature. It is the general statement of the happenings in the nature after repeated observations and experimentations. So it is the general statement. So conclusion, what you are drawing. It is the conclusion, or I can say it as the result of that experiment. So what conclusion you have drawn from the observation and experimentation of the natural phenomena. So what are the happenings in the nature? You have observed. The first step of scientific method. You have observed very keenly. You have to done the experiment on it. And from that, you got one conclusion. So those conclusion you have written in the, you have given in the form of a statement. Those conclusion are given in the form of statement. So those statements are known as laws. How it is? So Newton's first law of motion. So what it says? Every body will continue in the state of rest or in the state of uniform motion along a straight line unless and until an external force is applied. This is the statement, generalized statement of the happenings in the nature. What has happened? The body continue to be at the state of rest. If we keep a book or keep any stone, anything, so that will be there years together unless and until we push it or we pull it. So this is what Newton has observed. The body continued to be stayed at that point only, at that position only, years together. A body continued in the uniform motion. It never accelerated. If it is to accelerate, you have to apply force. If you want to change the direction, if you are moving on a motorcycle, if you want to change the direction, so you have to apply the force. In that direction, you have to apply the force. Otherwise, it will continue to move in the straight line. So Newton has observed these happenings in the nature. He observed all these things keenly at different positions under different physical conditions. He carried the experiment. Years together he has worked on it, and then he come to this conclusion. He made the statement of the conclusion drawn from his experiment, and that conclusion, that statement what he has given, now we are saying it as a law. So since this law is the happening in the nature, there is no reason, nothing, we have applied nothing there. What is happening in the nature in the form of a statement, we are writing. So therefore, there will not be, there will no ifs and buts here. Why the body has to be at rest only? Or if you see in the Newton's law of gravitation, why the two bodies has to attract? Why not they repel? Why they are only attraction force is there? Why there is no repulsion force? How charges, like charges, so repel in the same way. Why these masses are not repelling? So no answer for that. You cannot ask for a law, because what is the happenings in the nature? So that itself they have observed and experimented, and general statement they have given. They are not giving any reason for that. In the law, they are not giving any reason there. Therefore, we cannot question the law. Why it has to happen in this way only? As I said, why the two bodies has to only attract? Why not they repel each other? Why the charges have both repulsion as well as attraction? Why not only attraction like in the massive bodies, like gravitational force? So there is no answer for that. Just what they have observed, what they have experimented, they have given the general statement for that. That's all in the law. But there is other theory. So here comes the prediction. In theory, we can guess. They have given the law. Why there is only attraction? The intelligent people, they start to give the reason for that. They start to give the reason for that. The evolution of the universe, we have not seen. Just what we are seeing, the stars, all those things. But some intelligent people, they started to think because of the Big Bang theory, the universe might have exploded and it is continuously moving away from one another. Big Bang theory, we say it. Theory, it is the guess. It is the guess. It may be possible, may not be. They have not observed it, they have not experimented it, just they are doing a guesswork. So they try to give the reason for the naturally occurring phenomena. Why they are behaving so? They try to give the reason for that. And those reasons, this is the imagination of the intelligent people. It is not true. It may be true or may not be true. Here, it has to be true in law because they are observed years together. They have experimented years together, and lastly they have come to the conclusion. But in theory, it is just their imagination of the intelligent people. Why it is happening so? So that is why the theory can be discarded. If any other person, another intelligent person, another scientist, if he comes and he explains it in other way, so that becomes other theory. This theory will be discarded. The previous theory is discarded, and the new theory will be put forth. So that's what we have seen in the atomic models. Atoms, the tiniest particles. So we have been saying the nucleus is the central portion of the atom. How we came to know? Through the Rutherford alpha scattering experiment. Through the Rutherford's alpha scattering experiment. So what it is? If this is an atom, nucleus is present here. So an high energetic alpha particle is incident here. So alpha particle, which is positive in charge. So this alpha particle, so rather than going into this atom, so what it does, it changes its path. Here at the center, it reversed back. So at this point, it has changed its path. It has changed its path like this. Why this has reversed its direction? This particle, why these particles are changing their direction? So Rutherford thought that there must be, if this is positive charge, there must be a positive charge which is present at the center. So because of that, these alpha particles are scattering rather than penetrating through that atom, they are scattering. So this is his imagination. So through that imagination, the nuclear size, the presence of nucleus, the nuclear size, all these we have estimated. So this is his imagination. So this we say as a theory. It is the intelligent, it is the imagination of the intelligent people. What occurs in the nature? This occurs in the nature. And he gave the reason for that. Okay, and this we say as the imagination of the intelligent people. So that we say it as the theory. So this we can say it as speculation on the basis of it is speculation. It is the speculation on the basis of these laws in the sense naturally occurring phenomena. Speculation, the guesswork, the guess, what they have, the imagination, what they have made on the basis of determined laws. They start to guess on the determined laws. So that we say it as a theory. So as I said, so we cannot question this, but we can question. We have every right to question this because it is the guesswork. Whereas this is the experiment conclusion of the experiment, conclusion from the observations, what they have drawn. It is imagination of the naturally occurring phenomena. So therefore, we can question it, we can discard it, a new theory can be put forth. Okay, so this is about the law and theory. So what you have been studying these terms. What do you mean by law and what is meant by theory? So now moving on to the next part. What are the different branches of physics? So this physics is mainly classified into two domains. Field of field of study, two domains. So they are classical physics and quantum physics. Classical physics and quantum physics. So this classical physics is macroscopic. It is the study of macroscopic bodies. Macroscopic. Whereas it is the study of microscopic bodies. So macroscopic, where we have Newton's laws of motion, Newton's law of gravitation for the bodies, which is macroscopic, which has got a definite size. So such physics we say it as classical physics. Mainly in this we have mechanics, thermodynamics, then we have electrodynamics, then optics. So these are the different branches we have in the physics. So this mechanics, as you know, as you study, you have been studying. It is the study of the bodies which are under motion. It is a branch of physics which deals with the bodies which are in motion or even in equilibrium also. In equilibrium or in motion. So that study we say it as a macroscopic. This mechanics, that study we say it as a mechanics. So this is a macroscopic bodies. The size of the bodies are large. The study astrophysics, astronomy. So all these will be in this. The study of universe. So we are in the macroscopic study, we can say that. So the branch of physics which deals with the study of motion of the body, we say it as mechanics. Thermodynamics. It is the study of heat and interaction with the interaction of it with the matter. Interaction of heat with the matter. Study of heat and interaction of it with the matter. This branch we say it as thermodynamics. And then comes electrodynamics. Electrodynamics. So motion of the charges and their effect. In fact, in this electrodynamics, we have other two branches we can say electrostatic and magnetism. Even we can say it as current electricity, electrostatic, current electricity, magnetism or magnetostatic. So it is motion of the charges. It is a study of charges and their effect. So that study we are doing in the electrodynamics. Whereas optics, as you know, it is the study of light. It is the branch of physics where we are studying about light. Okay, so these we say it as classical physics or Newtonian physics. Before 1890, before 1890, so whatever we have, all those in the classical physics. We have mechanics, thermodynamics, electrodynamics, optics, and many other. So few to mention here. Whereas in classical. In fact, I must say here it is modern physics. Classical and modern physics. Modern physics. So in this we have quantum physics, mainly quantum physics and relativity, theory of relativity, modern physics. So which is microscopic level, quantum physics and relativity. Einstein's theory of relativity. So these are the two branches. So where we are studying this. It is classical physics and modern physics, microscopic like atomic physics. We can say atomic physics, nuclear physics. So those things we can study here. Okay, so these are the different branches. Classical, the old physics. This is modern physics. What we have before 1890 and what we have after 1890. So after quantum physics here. So then is scope and excitement of physics. Scope and excitement of physics. So already in the first class, something I tried to explain the scope of physics, what range we are going to study, what is the scope of studying the physics. As I mentioned earlier about to what range of mass, to what range of length, to what range of time we can study here, starting from the microscopic particles, very small particles, the tiniest particles, or I can say it as elementary particles, like proton, neutron, electron, many other elementary particles like mesons, bosons, many other particles are there. That study also is here. But we'll take it as mass of the electron. 10 around 10 to the power of minus 30 kg. To mass of the universe plus it is plus 10 to the power of 55 kg. So this long range of different mass particles, different mass bodies we will study. Starting from 10 to the power of minus 30 kg electron we are studying, and also we are studying the universe. The estimated approximate mass of the universe is around 10 to the power of 55 kg. The estimated mass of electron is around 10 to the power of minus 30 kg. So this long range of mass of the bodies we are studying here. So lengthwise, as I said, size-wise, 10 to the power of minus 15 meter, which is as 1 Fermi, which is the size of the nucleus, to around 10 to the power of 27 meter. So, which we say as the size of the universe. Starting from nucleus, the size, we are estimating the size of the nucleus using the Rutherford experiment that we are studying in the physics, and also the approximate estimation of the size of the universe also we are studying here. So from time wise, 10 to the power of minus 22 second 2, which is time taken by the light to travel through nuclear size, very small size. What time it will take to pass through that nuclear size, so that we can estimate to the estimated life of sun around 10 to the power of 18 second. So these things, this large range of these dimensions, mass, length, and time, we are studying here. So this is the scope of our physics. So this large range of these dimensions we are studying. Then what is the excitement of physics? So physics answers for many naturally occurring phenomena. Why the sky is blue? Why horizon will be red in color during sunrise and sunset? Why a ship which is made up of iron, it will float? How the water will reach to the top of the leaf of a tree? It explains. So not only that, even the modern gadgets like TV, mobile, robots, all these works on the principle of physics. In the medical field, many investigations we can make with the by using the principles of the physics. So we can transmit the sound signals to a very long distance, kilometers together, without any disturbance, without any decrease in the intensity. We can transfer it from one point to other point. So all these based on the principles of physics. So this we say it answers for the many questions of the natural phenomena. And also in the modern days, in the technologies, in different technologies. So these principles in different technologies, these principles we are using. So this is the excitement of physics. We are studying microscopic study also we are doing, macroscopic study also we are doing in physics. That itself is the excitement of physics. So this is one of the very important question for the theory. Right? Explain the scope and excitement of physics. They will ask. So this is the scope, and for the excitement, so different phenomena of the nature the physics explains. So different in different technologies, the physics principle is involved. Without physics principles, so the technology cannot grow. So this is the excitement of the physics. So now we'll move to another important concept. So that is basic forces in nature. Basic forces in nature. So what are the different forces that there are? So we have been in the daily life, we have been seeing different forces. Force of interaction, force of contact, viscous force, many other forces we are seeing at the macroscopic level. At the macroscopic level, the force of attraction or repulsion between the charges. The force of attraction or repulsion between the magnets, poles of the magnet. So many such forces we are seeing. But as I mentioned, the thirst for the physics is unification. So all these different forces are unified. They are explained in the macroscopic level by just two forces. They have unified these forces and in the macroscopic level, and we have two different forces at the macroscopic level. Otherwise, there are many forces: frictional force, aerodynamic force, viscous force. So many forces: force due to contact, electrostatic force, magnetostatic force, many forces we have. But all these forces are explained by only two forces. They have unified all these forces. And just we have two forces. They are gravitational force and gravitational force and electromagnetic force. This is at the macroscopic level. In the microscopic level, we have two forces there. That is strong nuclear force. Strong nuclear force and weak nuclear force at the microscopic level in atoms, nucleus. We have these two forces in the nature. So these are the basic forces. Many number of forces we are seeing in the nature, but all these forces have been unified, and so they have given four forces. And even they tried, and even trying to unify these forces also. Rather than having these four different forces, one or two different forces only to have. Even they are trying to unify these forces also. So as you know, the gravitation force is the weakest force in nature. So if you see the magnitude wise, the force due to gravity, force of this ratio, if you see ratio of these electromagnetic force, strong nuclear force, weak nuclear force. If this is taken as 1, the gravitational force is taken as 1, so this will be electromagnetic force is 10 to the power of 36 times stronger than 10 to the power of 36 times stronger than this. Whereas nuclear force is 10 to the power of 38 times stronger than this. Stronger than the gravitational force, 100 times stronger than the electromagnetic force. 10 to the difference is 10 to the power of 2, which is 100, around 100 times greater than this. Whereas the weak nuclear force, it is weaker than the electromagnetic force. It is around 10 to the power of 25 times stronger than the gravitational force. Of course, weaker than the electromagnetic force, because electromagnetic force is 10 to the power of 36. So this is the comparison of the different forces. So as you are seeing, this is the weakest force, gravitational force is the weakest force, whereas the strongest force is our strong nuclear force is the strongest force. So what are the properties of it? Properties of gravitational force. Properties of gravitational force. So what are these? As I mentioned, this is the weakest force in nature. Weakest force in nature. 10 to the power of minus 38 times weaker than the strong nuclear force. It is the weakest force in nature. Whereas it is a long range force. It is a very long range force. So all the in the universe, all the planets, stars, so all these are governed by this gravitational force. Whole universe is governed by this gravitational force. So that is why it is a very long range force. To the size of the universe it extends. So therefore it is a long range force. According to Newton's law, for this we have F is equal to G into m1 into m2 divided by d square. This force is directly proportional to product of the masses of the two bodies. It is directly proportional to product of the masses between which we are seeing the gravitational force. And other property is it obeys the inverse square law. One of the important concept here, inverse square law. The two quantities are inverse and also the square, inverse square law. It obeys any two quantities if they are. If A is one quantity and B is another quantity, if it is related like this. So this we say as inverse. It is inverse. These two are inverse. And here it is a square, inverse square law, we say it. It obeys inverse square law. So any two quantities, if they are obeying like this, A and B are the two quantities. A is inversely proportional to B square. Like force is inversely proportional to D square. So this we say as inverse square law. It is a central force. What do you mean by the central force? The gravitational interaction between the two bodies will be from the center of this to center. From the center of mass, one concept will come there. So right now, it is from the center of this body to center of this body. If you want to measure the distance, I think in your lower classes you might have studied. So from the center of this body to center of this body, you will measure the distance. It is because the gravitational force is a central force. In the sense, from the center of one body to the center of another body, the force acts. So then, it is a conservative force. Gravitational force is a conservative force. What do you mean by this conservative force? So here, work done, a force is said to be conservative force. If work done does not depend on the path the two bodies are moving. It is independent of the path moved by the bodies. How it is? If you have two bodies, the force of attraction is like this. Okay. If we move it somewhere to this extent, either you move it in this way, or you move it by this path, or you move by this path. What force of attraction is there between these two bodies? What force of attraction is there between these two bodies? Either you bring this body in this path or in this path, or by any. So at present, what is the position of the two bodies? Position of the two bodies, it does not depend the path that you are bringing. Okay, so therefore we say it as this is if it is so, then we say it as a conservative force. Such force we say it as path independent. If the forces are path independent, then such forces we say it as a conservative forces. Write down this. So next is the gravitational force between these two bodies. If it is, if a third body comes in between, it is independent of the other body. If a third body comes in between, so what is the gravitational force between these? The gravitational force will remain same. It does not alter even if you bring a third body in between. The gravitational force is independent of the bodies which come in between. So there sets other force of attraction between this and this. There sets one force of attraction, this one force of attraction. Because of the entering of this body in between these two, the force will not decrease, either it decrease or it increase. The force will not change here because of the entrance of this body between these two bodies. It is independent of the body. The gravitational force between the two bodies is independent of the third body, which has. So this is. So these are some of the properties of gravitational force. In the tomorrow's class, so we'll see the properties of other three different forces, and also we will see the law of conservation of different quantities. We will see. Okay, so here we stop. Thank you.